Again, an old school lesson in college algebra prep today of writing equations of lines. Got two main guys that we've been using, even though there's other forms. Slope-intercept form, which is what we're very used to, y equals mx plus b. They call it slope-intercept form because you can tell the slope and the y-intercept just from looking at it. And point-slope form of an equation is when they give you a point, boom, and you have the slope, boom, you can use this form to write an equation of the line. So let's get started. Write the equation of the line described in slope-intercept form. So they mean they want the final answer in y equals mx plus b. It all depends on what they give us. If they give us a slope and a y-intercept, a slope and a y-intercept, we are in good shape. So first one, did they give us a slope? Yes. Did they give us a y-intercept? Well, maybe. This point right here is 0, 4. If you graphed it, isn't 0, 4 totally on the y-axis? So boom, this is the y-intercept. 4 is the y-intercept, so y equals the slope of 4/3. You do need an x next to that, plus 4 because it is a positive 4. Bing, bam, boom, way too easy. They gave me the slope. They gave me the y-intercept. Don't make it any harder than it has to be. The slope, boom, 1/3, and oh no, an x-intercept of 5. Let's go back here for a second and look at this y-intercept. You can tell just by looking that this is a y-intercept because the x value is 0. That's like a little opposite game. If the x-intercept is 5, that'd be like right here. That would be at the point 5, 0. The y value is 0. So this is hidden language here that they want you to write this ordered pair, the x-intercept of 5, 0, like so. And now we have a point and we have a slope. We shall use point-slope form. So this is x1, y1, like you know that little point that they gave us, and this is m in that case. So we'll start our formula with y minus y1, which is 0 in this case, equals m 1/3 times the quantity, that means we're going to put parentheses, times x minus x1, which is 5 in that case. So we got all this awesome work to do right here, and then we will distribute Mr. 1/3 through. So y minus 0 is plain Jane y. We're just going to keep it like that. 1/3 times x is 1/3 x. And 1/3 times a negative 5. Well, I do the sign first. That's going to be negative. You got a positive times a negative. And I'm going to make this a fraction so I can multiply them together easily. 1 times 5 is 5, and 3 times 1 is 3, and we're done. We've got y all by itself. Y equals mx plus b in that case. Slope of 1/3, y-intercept of negative 5/3. So here they give me a slope, boom, and they give me this point, and this is not the y-intercept because this x value is not 0. So since I have a point and a slope, I will use point-slope form. This is x1, y1. So y minus y1, which is 7, equals the slope, negative 2, times the quantity of x minus 3, which is x1. So then we do the distributive property next. We clean that up. Mr. Y minus 7 comes down. Please show work the same way I do. You're just bringing stuff down. That makes you proper mathematically. Sign, it's a negative times a negative, so that's a positive. 2 times 3 is 6. And then finally, we shall add our 7 over. So it did not get affected by the negative 2x, and 6 plus 7 is 13. Put a box around that since that's our final answer. And that's what we want to do. So we started with point-slope form because they gave us a point and a slope, and they want the final answer in slope-intercept form, so we just kind of cleaned it up a little bit. Let's do that again. They gave us a point here. This is not the y-intercept because this value is not 0, and they gave me a slope. So I will start in point-slope form. Y minus y1 is 3. It's the y value of the point they gave you, times the slope, which is 1/2, times the quantity of x minus whatever this guy is. In this case, it's 2. Remember, in the formula, there is a minus there, so it's minus that x1 value. Distributive time. Don't let the fraction scare you. It shouldn't be an equal sign. Sorry. Don't let the fraction bar scare you. So y minus 3 equals 1/2 times x is 1/2 x. I figure out the sign next. It's positive times a negative, so that's going to be a negative. And then I notice that this guy, boom, goes into this guy evenly. How many times does 2 go into 2? Once. Then take that result times your numerator, and you get yourself a nice little 1 right there. And then we could add 3 over to get y all by itself. So we have to get y all by itself. -1 plus 3 is 2. If you need to show these little baby steps right here, I got no problem with that. You can do that. But I'm hoping that maybe at this point in your algebra life you can get away from doing that. But again, no harm done if you got to show the baby steps. Do it to both sides. If you're going to do it to one side, do it to the other side. So, oh no, here's a point, there's a point. I got 2 different points. You know what they didn't give me? The slope. So, we will find the slope. Slope equals, I like to put this little m equals when I do slope. It's the difference of the y's. So, here's x1, y1. Here's x2, y2. 2 different points. We're going to do the y's on top. So, y2 is -3. Take away y1. We found the slope many, many, many times before. Then x is on the bottom. x2 minus, a -2, so minus a minus becomes a plus. All those great algebra things. Upstairs, -10. 3 plus 2 is 5. And yes, 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 we shall reduce everything. -10 divided by 5 is a -2 in that case. So this is our slope. Now, to write the equation, I need a point. Well, they gave me 2 of them. I don't care which one we use, so I'm going to pick this one. I'm going to use this slope right here and this point. So y -7 equals my slope of -2 times the quantity of x minus a -2 minus a minus becomes a plus. And then we shall distribute. Bring Mr. y -7 down, again showing work just like I do. It's all part of the test, and then we distribute to get us a -4. Then we'll add 7 to both sides to keep this thing balanced. -4 plus 7 is a +3. Box it, because that's our final. So here, they did not give me the slope. I had to find that first. Over here, nice, I got the slope. That's awesome. And here's a point right here. So I will use point slope form. Y minus y1 equals the slope times the quantity of x minus a -4, which turns into be a plus. Distributive property time. So all this stuff comes down. Boom, boom. You don't need to draw those arrows. I just do that for your benefit so you can see what I'm doing. I'm doing the distribution right there. And then we will add 6 over to give us a final. So we've been doing this stuff for years and years and years. The thing that's going to get us is the signs. Minus a minus becomes a plus. Watch adding this over if you have to. Do the opposite. Yeah, you don't always add it over. If this is a minus, you will add it over. If this is a plus, you subtract it over. All right, let's keep on keeping on. So they give me a slope. Boom. They give me a y-intercept. Bingo. We've got everything that we need to put it in slope-intercept form. Slope with an x next to it, plus 4. Done. I did not need to use point slope form because they totally did all of that for me. So I've done 7 of them. Why don't you take this slope and this regular old point right here and put them into slope-intercept form and clean it up. Please pause the video and get that done for me. Since we all have calculators, if you want to see how to punch that in your calculator correctly, to do a fraction, you got to put it in parentheses. So if you wanted to take 13/5, I did 13 divided by 5, put it in parentheses, take it times 5, and that'll get you your 13 back in that case, just in case you were a little confused on how I did that. But when this number goes into that number evenly, we're in good shape. See, I'm not done though, baby, because I got to subtract that 7 over. See how it's a plus 7? I got to subtract him over. So 13 minus 7 is 6. So there she is. That's our equation of that line. Ooh, look at this. Write the equation of the line in slope-intercept form. I need a slope, I need a y-intercept. Well, boom, there's my y-intercept right here. That puppy's at 9. That's where it crosses the y-axis. Remember, this is an x-intercept. We want the y-intercept right here. To find the slope, I can just count a little rise over run. Rise is up and down. I can tell this slope is negative because this dude's going down from left to right. As you read from left to right, this guy's going down. So it's down 1, 2, 3, 4, 5, 6. Down 6. And then the run that I do is to the right 2. So that's negative 6 over 2, which totally reduces to negative 3 over 1, which we don't put that. And that is our slope. So y equals negative 3x. Y-intercept of 9 plus 9. So just had to read the graph to see where the y-intercept was and count for the slope. We shall do the same thing again. Here's the y-intercept. It's where it crosses this y-axis at 0. Slope, it's a positive slope because this guy goes up from left to right. So rise 1, 2, 3, 4, 5 to get to that point right there. Run 1, 2, 3, 4. So 5/4 does not reduce. We will do y equals our slope times x plus the y-intercept, which is 0, but I'm not going to write plus 0. I think that's very mathematically immature. We don't need that. If it's plus 0, we just leave it off in that case. So there she is. We did not need to use point slope form because we had all the ingredients we needed for slope-intercept form. We had the slope by counting, and we had the y-intercept by looking. And then finally, parallel and perpendicular lines. Remember that parallel lines have the same slope, and perpendicular lines have opposite reciprocal slopes. That means if I had a slope of 2/3, opposite means change the sign, reciprocal means flip it over. So do you see how this is a positive number right here? To get my opposite slope, it's going to have to be negative, and then I got to flip this guy over. If you had a slope that was already negative, say negative 1/2, your perpendicular slope, since this is negative, needs to be positive, and then you flip him over to be 2/1. You don't change like both guys' sign. They're like, well, the 2 was positive. Shouldn't he become negative? No, this entire number right here is a negative number. So our opposite of that should be positive. So that was a quick little refresher on opposite reciprocals. So let's rock with this. I got to write an equation that goes through this point, and it's got to be parallel to this line. Well, this line is awesome for us because y is all by itself. It is in slope-intercept form. I can tell what the slope of this line is just by looking. The slope is 1/2. The question is, do I want to use the same slope or do I want to use the opposite reciprocal slope? It depends on the p word. This p word is parallel. So parallel means we're going to use the same slope. Since this guy has a slope of 1/2, this guy is going to have a slope of 1/2. So I will use this point and this slope to do point slope form. So y minus 2 equals my slope of x minus a -4. That became a plus. Distributive time. Boom. 1/2 times x, 1/2 x. And 1/2 of 4, baby, that's 2. Or you could say 2 goes into 4 twice. Take that times the numerator. Or you could punch it in your calculator like I showed you earlier. Then, got to finish by adding 2 to both sides. Because we got to get y all by itself. We like it when y is all by itself. Like if I asked you to graph this, you could do it. And it would be parallel to this guy because they have the same slope. So here on the next one, they say go through this point. Okay. P word is perpendicular to this line right here. So I'm going to take you way back to geometry class. Remember this upside down capital T? That means perpendicular, and M means slope. So I always like to put perpendicular slope equals. Since this is a -3, I need the opposite reciprocal of that. I need to flip him over and change the sign, so that would become a positive 1/3. The perpendicular slope is 1/3. So I will now go through that point. Y minus 1/3 times x minus 3. So here was my point, boom, boom, and here is my slope. distribute, this sign should turn out to be negative, and then 1/3 times 3, I like this because 3 goes into 3 once. Take that times the numerator, and you still get a 1, and then we will add the 1 over. Okay, I will add the 1 over. -1 plus 1 is 0, so I'm not going to put plus 0. I'm just going to leave it like this. And these two lines, if you graph them, are perpendicular, which means they intersect at a 90-degree angle. Okay, next guy, check it out. We got to go through this point, so through the red point, and then my P word is parallel to the line that goes through these 2 points. Well, what? All right, here's what I need. When we're doing parallel and perpendicular stuff, I need to know the slope of the line they're talking about. They're talking about the green line. So I got to find the slope between those green points. y2 minus y1 over x2 minus x1. Upstairs, -4. Downstairs, -2. And everybody knows if I was to say this out loud, what a negative divided by a negative is. A negative divided by a negative is positive. But if we go too fast, sometimes we think this answer should be negative. You know that negative divided by negative is a positive. So I got a slope of 2, and I got to go through this point. The question is, do I use this 2? It depends on the P word. The P word is parallel, and parallel lines have the same slope. So yes, we will use this point, this slope of 2. So since they gave me a point, and this is not the y-intercept because that's not a 0, I will do y minus a -1 equals the slope times the quantity of x minus 1. Distributive property. 2x minus 2, and then we shall subtract our 1 over 2x minus shwee. So parallel. Had to find the slope of the 2 points that they gave me first. We're going to have to do the same thing over here, except, oh no, bro, they use the word perpendicular. So we got to go through this point, but we have to find the slope between these 2 guys first. So we will do it. Slope equals y2 minus y1 over x2 minus, oh no, look at this. This is going to give me 9 over 0, and oh no, 9 divided by 0. Look at that, error. You can't do that. That is undefined. And that'll take us way back, undefined, if I could spell. That'll take us way back to realize that this dude right here is a vertical line. All vertical lines have undefined slope. Well, to be perpendicular to that, I need a horizontal line. And horizontal lines equations are easy. They're just y equals some number right here. What number do you put? Well, what point are you going through? We're going through 4, 7. This is the x value. This is the y value. So shouldn't y equal 7, since that's the y value of the point we want to go through? So vertical lines have undefined slope. Horizontal lines have 0 for a slope. This guy right here, he's got a slope of 0. It's the same thing as y equals 0x plus 7, because 7's like the y-intercept of that guy. But we don't put this. We don't put 0x, because 0 times x is 0. It's just y equals 7, so we won't do that. Horizontal lines only have y with it. This guy's equation is actually x equals 3. Do you see how both x values are 3 in that case? So holy memory lane, Batman. Let's try just the last 2, man. Passes through this point right here. Boom. Perpendicular is our P word to this. This is a line, and we're in trouble now, baby. A lot of people think that the slope is always the number in front of x. That's only true if y is all by itself, baby. Y is not all by itself here. We need to get y all by itself. How do I get y all by itself? First move, subtract the 2x over. So I'm going to show baby steps just because. You don't have to do this, but this is my first move. Those go away. Do you see how y doesn't come down? It is a minus y. And then we'll always put the stuff with the x. See, these aren't like terms, so we'll have a minus 2x and a plus 4. We're close. Y is almost all by itself, but there's this times -1. We shall divide everything by -1 to make this work. And this is the line that they actually gave us. But what we like about him now is I can tell what his slope is. The slope of this line is 2. I got to go through this point though. And the question is, should I use the 2 or should I take its opposite reciprocal? It all depends on this P word right here. So perpendicular is the word. I need the perpendicular slope. Since this guy is the slope of 2, I need the opposite reciprocal of 2, which is a negative 1/2. So I need to use this slope and go through this point. Holy cow! Y minus a minus 6. Slope of negative 1/2 times x minus 8. Distributive property. Negative 1/2 times x is negative 1/2 x. Check this out. We're going to do sine next. It's negative times negative, which is a positive. Half of 8, baby, is 4. Or you could say 2 goes into 8 4 times. 4 times 1 is 1. And it had to be positive because you did negative times a negative. And now we shall subtract the 6 over. So forgot my negative there. And 4 minus 6 is a negative 2. So holy mackerel. That was a good one because they didn't have y all by itself. If we go back here where we had one of those, see they had y by itself. They had y by itself, so you could tell what the slope was just by looking. But here I couldn't do that. And lastly, all they want us to do is put it in slope-intercept form. So they put it in point-slope form for us. They just want us to do the work. And here's why it's going to be nasty this time. So Mr. Y minus 2 comes down. Of course, we've got to do the distributive property. And oh no, this ain't going to be nice. How do I know that? Because you see this 3? Meow. He does not go into this 7 evenly. So what we do is old school multiplication. To multiply fractions, it's nice when both numbers are a fraction. I'm going to do the signs first. It's a positive 2/3 times a negative. So boom, that's negative. Numerator times numerator. 2 times 7, 14. Denominator times denominator, 3. So that wasn't too bad. I could actually do that without my calculator, and I'll bet you can too. But see, we're not done. We got to add 2, and adding fractions is the things that we don't like, and that's where, thank you, calculator, dude. We are just going to let the calculator do the work for us. We are in college algebra prep, baby. So let me clear this out. Clear. Where'd you go? Here. And here's what I'm trying to do. I'm trying to do a, watch this, see it's negative 14/3. So to use this graphing calculator, there is no fraction button. You just got to put their fractions in parentheses. But you see how I made him negative? Negative 14/3. I need to add 2 to him. So plus 2. And it's going to give me a decimal back every time. So now I'm going to make this large so maybe we could see it a little bit better. It gave me a decimal back. Well, maybe you learned this back in Algebra 2. Maybe you don't know it. But to turn this into a fraction, it's a cool little sequence called Math Enter Enter. This button right here says Math, hit it. And if the first option there is, you want to change it to a fraction, okay, so I'll hit Enter. And then I just hit Enter one more time, and it will do it for me. So negative 8/3. So to do that again, it was Math, Enter, Enter. We'll do that a lot this year. So negative 8/3 is what that bad boy turned out to be. And there's our final one. So, yep, when we want to add fractions, we'll let Mr. Calculator do the work for us. That's what they're for. So, cool. All right, that was an old school writing equations and lines. Let me know if you have any questions. Have a good one.